Hello and welcome to my channel. In this video I will show you how to work with Numpy in Python. So what is Numpy? Numpy is a Python library that has provides the capabilities to create n-dimensional arrays and provides the tools to be able to perform complex mathematical operations using those arrays or on the arrays. So this tutorial is done using terminal. If you are working on Windows, you can repeat this using the command prompt. So I'll launch Python and then I will import Numpy. There are several ways to import Numpy, but in this case I will import Numpy as NP, which is almost a standard way of importing Numpy for scientific codes and papers and researches. So yeah, Numpy is imported. First of all, I'll begin this tutorial by creating a one-dimensional array, and I'll call it A1, and I do that by calling numpy.array, and then one-dimensional array, so I'll just do 1, 5, 9, 6, and then enter, and then I have my one-dimensional array. So if I call A1 now, you see that it's a one-dimensional array. I can check the dimension of this array by calling a1.ndim and enter, and it gives me shows me that it's a one-dimensional array. I can also check the data type of the values in the array by calling a1.dtype, and in this case is in 64. That's integers. Also, at the point of creation, I could have just made one of the values a double, a float in Python, a float, and then I create the array, and then this time when I check the d type of the array, it should be a float. So yeah, that's a float. So making one of the values a float is enough to make the whole array a float, the d type of the array. Also, at the point of creation, I could remove this, I could make it int again, it's int again, and then at the point of creation I could specify the d type, and there are several data types in Python. In this case I'll use the numpy float 64 and then enter, and then when I check the d type of the array again, it's a float again. So there are several ways to create your arrays, and you can specify the data type using several approaches. Now this is a 1D array, as we showed by calling the a1.dim here. It's a 1D array. It's also possible to create a 2D array, and we create a 2D array. I'll call it a2 by calling mp.array again, and then this time I'll need two brackets because it's 2D array, so two square brackets, and it's essentially a list of numbers. That's why the first list contains this other list of numbers. So I can just call it 2, 8, 10, and then I'll create the next one, 9, 1, 3. It's just a random array I'm creating, and then enter. So now I have my second array, which is 2D now. So I check the dimension of that using the ndim, a2.ndim, and then we see that it's 2D. The data type, of course, is integer. I could also specify the data type using the approaches I already showed by either calling it, giving it this command, or by making one of the values a float. We have two arrays, A1 and A2. One is 1D, one is 2D. There are several operations that one can perform on these arrays. The first one I would like to show is the size. You can check the size of the array by calling a1.size, and this gives me 4. So this array has a size of 4 components, 1, 2, 3, 4. In a similar way, if I check the size of A2, it gives me 6. It has 6 components or 6 elements in it. I could also check the shape of the array that I'm creating. So a1.shape will give me the shape, which shows me that I have 4 elements in the first dimension and no elements in the second dimension. I could check the shape of A2, and then we have a 2 by 3. So we have 2 in the first dimension and 3 in the second dimension. So this 1, 2, 3. There are other functions I could perform. I could, for example, check the sum of the elements in the array. It works in the same way for both the 2D and 1D arrays. To perform the sum, I call numpy.sum, and then I just pass this array I want to work on. So it's A2, and then that will give me the sum of all the elements in this array, and it's 33. If you add all this, it should use 33. It's 33. This is 10, this is 10, this is 10. So 30, 33. Yeah, so that's right. In the same way, for A1 we could get the sum, and it's the same way. So I could also check the maximum value in my array by calling numpy.max, and then I'll pass the same array, the A2. I could also check the minimum in the array, and that gives me 1. Yeah, which is the minimum value in the array. For example, I could sum in the 2D array. I could sum the horizontal components or the vertical components, and you do that using axis. Horizontal axis is axis 1, and the vertical is axis 0. So for example, I want to sum the components of A2. I'll call A2 again. I want the sum of horizontal, so this, and this. So the sum, I want 11, 9, and 13. I do that by calling the sum, and then I specify an axis. First of all, give the array, and then axis 0 is the vertical. And then if I do this, it gives me the sum of the components in the horizontal and in the vertical. I could do the same thing for the horizontal by changing the axis to 1, and then it gives me the horizontal. So the sum of this is 20, and the sum of this is 13. I could also check the mean value of the components in the same way by calling numpy.mean, and then I pass the array, and it gives me the mean. I could also check that mean, I believe, for the axis. I haven't tried that before, but I believe it should work. I don't see why it shouldn't. Yes, it works. Could check the square root, or compute the square root by calling numpy.sqrt, and then you give that array, and then it will give you the square root of all the elements in that array. Also, we could perform log operations, logarithm operations. The natural log is the default log, so if I do np.log and then I give the array, it gives me the natural log of all the elements in that array. A2 again is this, and we know that log 1 is 0. Len 1 is 0. The natural log of 1 is 0. So if in this one I could call it, let's say t1, just like t1, and then you could also perform the exponential, so np.exponential, and then put a t1, and then it should give me the same, it should give me the a2. Yeah, so that's the a2. So I'll now proceed to show you more complicated ways of, or not complicated, but faster ways of creating arrays using NumPy. So the first thing I would like to do is, I'll call this A3. You can create an array of random numbers and specifically pass the shape. So I'll do that by calling numpy.random, and then I'll make it 3 by 4 and then enter. And if I call A3 now, you see it's an array of random numbers, 3 rows, 4 columns. In this array I could just go into it and assign a value to one of the components. Say I want to change this one. Yeah, it's in the third row, but in Python it will be the second. The Python counting starts from 0, so this is 0, this is 1, this is 2, and this is 0, 1, 2, 3. So if I want to change this value, I'll specify it as 2, 3, and then I'll make it 100. It didn't work. 0, 1, 2. 0, 1, 2, 3. Oh, okay, it's from the array. I didn't call it. I didn't call the array well, so it's A3. Okay, sorry about that. So now if I call A3, yeah, it's there. So A3, I've changed that value. So you can do this by assigning values. You can go into the array and just change the value of a particular array. I created this array using random.random, but there's also random.random sample. There's supposed to be an underscore. Yeah, there's supposed to be an underscore there. I don't know why it's not showing. Random.random sample, and you create a random array again. If I call the A3, it's another random array. It's different to this, it's just random numbers. And yeah, that gives me an array of random numbers. So I could check the shape of the A3.shape. It gives me the 3 by 4, which I specified here specifically. Okay, the most common way of creating arrays is using the arrange. function in Numpy, and I'll use it here by creating a fourth array and calling numpy.arrange, and I'll make it 10 elements. And also I could specify the D type, just like we did in the first two examples, the 1D array and the 2D array. And this I'll use the np.float 64 again. And if I call A4, it creates an array of floats, a one-dimensional array of floats. I could also create another array, or the same array, but I just reshape it into a 2D array. So 2 by 5, yeah, that works for the 10 elements. And then if I call A4 now, it gives me a 2D array of numbers from 0 to 9. That's 10 elements. So Python starts its counting from 0. There's also another very useful way of creating lists in Numpy using the linspace, and you're able to create arrays. Let me just demonstrate that. So I'll say A5 is equals to np.linspace, and then the first component you pass is the starting, the second one is the end, and then the number of elements. I want numbers from 1 to 10, and I want 6 numbers from 1 to 10, and that's it. I pass enter, and then when I call A5, you see I have 6 elements, 1, 2, 3, 4, 5, 6, and both the lower bound and the upper bound are included. So 6 elements from 1 to 10 with both 1 and 10 included. You can also create an array using zeros or ones. They have, Numpy has this np.zeros, and then you can just pass it the shape as you want, 3 by 7, and then we'll get an array. So if I call A6 now, it's all the components are zeros, and by default they are doubles, they are floats. Numpy also has the possibility of changing all the values in the array. So you can the A6 now is zeros. I can just fill it with any number that I want. So I'll just say 5, and then when I call A6 now, all the numbers are 5s. We can always reshape our arrays. We can flatten the array. A 2D array can be flattened into a 1D array, and vice versa. So for example, I would like to create a new type of array, or a new set of arrays. I'll call it B1 is equals to A6, and then I'll reshape the A6 to the size of the A6. And if I do this, I'll create a flat array. I hope that's not too confusing. I'm creating an array that has the components of the A6 that has been reshaped to a 1D array, because the size of this is a one-dimensional number, so I'm just picking the size, and then if I enter, and then I call B1, it's now a flat array. B1 is now a flat array. If I check the size of B1 dot size is 21. If I check A6 dot size, it's also 21. So this is one way of flattening the array. I could also just do B2 is equals to A6 dot ravel. To create an array, a flat array, it should be the same, exactly the same as the B1. If I call B2 now, it's the same. I have gotten a new array created from the A6, but now a one-dimensional array. So a 2D array has been converted into a one-dimensional array. Of course, this is horizontal. We could also do it in a vertical. For example, I'll call the A6 again, and then I will just try to make it horizontal by calling the V stack. That's like vertical stack, and then I'll pass the A6 in it, and then it gives me the components of now arranged in a vertical order. They are no longer flat but vertical. Maybe this will make it a little bit clear by assigning it. Maybe I call it T2, and then I call T2. We can perform common operations like additions and subtraction. So I'll create a new set of arrays so to perform addition, subtraction, and multiplication using Numpy arrays. So first of all, I'll create the first array. This time I'll create them very fast using np.arrange, and I'll create 12 elements dot reshape it into a 3 by 4 by 4. I can call C1 and you'll see it here. So it's 3 by 4. So C2, I'll create it np.arrange. Or this time I will use random 12 random numbers, and then I'll reshape it into a 4 by 3. And if I call C2, you see that it's 4 by 3. 4, 1, 2, 3, 4. 4 by 3 array. I could create a third one. Yeah, let me do that by just making it also 3 by 4, and I'll call it C3. So I have 3 arrays now: C1, C2, and C3. And for one-dimensional arrays, it's pretty easy to do additions and subtractions with them, but when you get to the more complex higher dimensions, then it really gets difficult. So if I recall, A1 was this. So if I create a second array, I'll override the A2. Okay, A2 is equals to a1 times 2. Let me just do it like this. So we have a2 now, and we have a1, so I can just do a1 plus a2, and that gives me the addition of this 1 plus 2, 3, 5 plus 10, 15, 9 plus 18, 27, 6 plus 12, 18. So that gives me that. So it's very easy to do this in one dimension, but in 2D, that's why I created the new set of arrays, the ones are called C1, C2, and C3. So in the C1, I could do, the first one is C1 is 3 by 4, and the last one is also 3 by 4, so I can add them. So I can say C1 plus C3, and that works. For addition, it works. I could also add them using np.add, and then I'll call C1 and C3, and that gives me the same values. So this is one way of performing the additions in using Numpy arrays. In a similar way, I could do subtraction by calling C1 minus C3, and that gives me that, or calling Numpy subtract. So C1, C3, and that gives me exactly the same. So this is the same as this. With multiplications, it gets a little bit tricky, because in one dimensions, if we recall, if we multiply a1 by a2, a1, let me just call it a1 and a2, and then we see, so a1 by a2, you can multiply them, the components go by each other, they are essentially one-dimensional arrays, so they just multiply themselves by each other. This times this gives us the 2, 5 times 10 gives us the 50, 9 times 18 gives 162, and 6 times 12 gives 72. But in 2D, if we were to do the same, it will not work for C1 and C3. Well, first of all, to do multiplication, the last dimension of the shape needs to be the first dimension of the second array. That sounds confusing. Let me call the arrays, and you see C1, and then C1 dot shape, yeah, that gives me 3 by 4, and C2 dot shape is 4 by 3, 4 by 3, and 3 by 4, so 3 by 4 by 4 by 3. If you understand matrix multiplication, you know that this you can multiply them, because the second dimension is the same as the first dimension of the second matrix. You can multiply them. But C3 dot shape, if you look at the dimension of this one, 3 is the ending, and the first dimension, it's not possible to multiply C3 by C1 with C1, or yeah, but you can multiply C3, C2 and C3, and you can multiply C2 and C1. If I do C1 times C2, we are going to have a problem, because it will not work in Numpy. What you can do is use the Numpy dot by calling np dot and then I pass the array C1 and C2, and then now I have the multiplication of the two arrays. I would also do that for C2 and C3. So this is multiplication. I prefer to always use this approach to multiply my arrays even when they are one-dimensional. I use the dot, the numpy dot. So we could also multiply C2 and C3 because this dimension and this are the same. So that's it with multiplication. Now I would like to show you how to do slicing in Numpy, because slicing of the arrays, the Numpy arrays, can be very useful when you are working with large data. Okay, so I'll create new set of arrays. I'll call the first one D1 and np.arrange, and then an array of 12 elements. I'll create a second one, but reshape it to a 3x4 array. And then I'll create a third array, a 3D array. I'll make it 4x3x5, and so in that case 4x3x5, so it should be 60, and I'll call this D3. So I'll just call D1, D2 and D3. So back to D1. This is D1. It's a one-dimensional array of 12 elements starting from 0 to 11. We will work with this first one to get the basics of slicing or indexing. So D1, the first, if I want this element, all I need to do is call D1.0 D1 0, and it gives me that element 0. So the first element in the array always has the index 0 depending on the dimension. In 1D is just one value. In 2D it will be different. When we get there, I'll show that. But the first element in the first dimension, you call it using 0. So I'll leave it at that. I will not complicate it. So the last element in this one, D2, is always D1. Still, we are working with D1. Has the index -1. So the last element is always -1. This is the last element, -1. So that's positive indexing starts at 0 and negative indexing starts at -1. So this first element is 0, has the index 0. This one well, in this case the elements are the values have the same numbers as the indices. In the positive, the positive indices. So if I call, for example, this 5, it will give me the 5. That's the value here. Now with the negative indexing, the last value is -1, and it goes backwards. So this is -2, -3, -4, -5, -6, -7. So if I want this value, I just need to call -7 and I'll get a 5. So that's the negative indexing. That's the basics. This is very relevant. If you get this at this point, the rest of it will be pretty easy because it's the same principle that you just build on in the higher dimensions. So now we'll go to the slicing of the arrays. We call it D1 again. It's still here. D1. First of all, I will show you how you slice in Python. You always start with an upper bound. So let's say my lower bound, which is 0. Then you use the colon, and then you give the upper bound. The upper bound in this case is 11, but that's the upper bound is always not included in the slicing. The lower bound is included, but the upper bound is not included. And then you give the steps what it should jump. So I'll just use 1, and this should give me the first 10 this part of the array. It ends at 10 because the upper bound is not included. So if I want to slice from 0, if I want this values 0 to 4, I'll just give D1. You can give the 0 or you leave it out and just, I want this one, so I'll use 5 because I know that the 5 will not be included. Give me the first 4 elements. I could also put the 0, but it's the same. You can leave the 0 out or you put it. I could also slice from a specific index. Let's say from a 4th index to the 4th index to the 10th one. So I want to start here and end here without including that one, so I want to end here. So that's it. It gives me, it's just slice that array out for me. Now this slicing also works with the negative index, the negative indices. Another thing I would like to show is that in slicing, the colon has the possibility of being coming before the index or after the index. So let me show what I mean. In this case, if I do it like this, it means give me all values from the beginning to this value, to this index 5, but don't include it. But if, for example, I gave it like this 5, and then in this case I'm saying start at 5 and give me everything else to the end. So the 5 will be included in this case, and to give me all the values coming after 5 with 5 included. So understanding this concept is very relevant because when sometimes you want to slice backwards or forward, knowing the location of the colon and what it means is very important. Now you can also perform negative slicing using the negative indices, and for example from 0 to 10 without the last one. I could use the same because we know that the last index is -1. If I call it like this, give me that. One way of looking at this is also, it could be relevant, but it could also confuse you. It's just saying give me all the values except 1, or give me all the values of the list except 1. If I make it 3, so it means give me all the values from the beginning except the last 3, and these are the last 3. The last 3 are 9, 10 and 11. So I hope this is not confusing you in any way, because it's also relevant. And if I want the last value, I call the last value by either calling the specific index, which I know is 1, in this case is 1D, or I could also make it a list by slicing the last part of it. I hope that's clear. Like I said already, I call D1 again. This is index 1, index -1, -2, -3 and so forth, and this is index 0, 1, 2, 3, 4, yeah, and so on. So I could slice the array and leave out the last 3 elements. For example, in this case I'm leaving out the last 3. I'll just leave it and not complicate it. If you perform a slice, you get an array out of it, but if you just specifically show the index, like I did with this this one, I gave the specific index, I got the value, but when I sliced it, I got an array out of it. And that is also quite it's good to know this, that when you are extracting your values, you should know if you are extracting just numbers or you're extracting arrays. Sorry about that. So with my array, my D1, with my D1 array, I could also perform the slicing of all the elements at a particular interval. So for example, I want to slice starting from 0 at an interval of 2. So I will do it by calling D1. I start from 0. I could give the index, so I leave it. I start at 0 and I want the whole array, so I'll use on the slicing over the whole array. So I'll use d1.size. That gives me the size of the array, so from 0 to the end, and then I give my size. I want it to jump, or to give it in the order at the interval of 2. From 0, the next one is 2, and then 4 and 6 and then 10. Similarly, if I do it using 1, it should give me all the elements in this array. That gives me all the elements in the array, and I could start from any of the indices. I'll keep this at 2, and I could have started from, for example, the 3rd index, and then in this case, if I start here, if I say start here and give me every second value, then it will give me this, that, and then the last one. Let's see if I'm right. Yeah, so that's it. It gives me that. So this way of slicing is also very important. Of course, in this one, we could just leave out this second one as well, and then it gives me the whole array again. So I could leave the upper bound. Once you leave the upper bound, so it means overall all the indices. And again, in this case too, if we leave it out, it gives us the same results. You could leave that out, but yeah. So I would like to also compare negative and positive indexing. So I call D1, and I want to slice values from the 4th index to this one. That's from this to this, without including the 10. How I could do it is, first way is by calling D1, and then I call the index, there were 4, and I go all the way to 10 because I want it up to 9, and this should give me the values I wanted from 4 to 9. I could perform the same operation using the negative indices by calling D1 again. I want these values again. I want 4 to 9 using negative indices. So all I need is this index. We know that this is -1. So -1, -2, -3, -4, -5, -6, -7, -8. So this index is -8. So that's my starting index, -8. And I want to end on this index without it being included. So it's -2. And if I enter, it gives me the same slice using negative indices. So this is one way of combining the indices. If you really understood it from the beginning, if you understood the basics of the indexing, then this shouldn't be confusing. We could also combine the positive and negative indices. For example, this is index 4 from positive indexing, and this would be 2, 3, 4. Yeah, so this would be -4. So I could combine the indices if I want these values, or let's take the values that I just got. Could combine the positive index, this, and this negative index here to extract these values by saying D1, and then I call the 4 and the -2, and that should give me the same. So you can combine the positive and the negative indices too to perform the slicing of arrays. Now, with this introduction or this demonstration in 1D, I would like to proceed to 2D and then 3D arrays. It gets a little bit tricky, a little bit confusing, but I took my time to explain this part because it's the basics, and once you get this, the rest of it shouldn't be that difficult to understand. So if you recall, I created an array called D2. I'll call it again. It's a 3 by 4 array, 3 by 4, and again, like I said previously, if you call D2 at the index 0, it gives me the values in the first dimension with index 0, and the first dimension is this. but in this case it's also an array. So if I call this, it will give me an array in the first dimension with its components. In a similar way, this last one, if I call d2 minus 1, it will give me the array at this location. It will extract exactly this array because it has that index. So as we can see, extracting the d at the index location minus 1 gives me this. The first thing I would like to do in the slicing is call the d2, and then I want to call all the elements, or I want to slice all the elements. So what I will do is the components in the first dimension and all the elements in the second dimension as well, and this will give me the whole array. It just gives me the array again. Here I could have just given a value. In this one I could have given a value, start at index 1 and slice everything. So it means that I don't want this. I want just this one in the first dimension. I want to start at this index and get everything. If we enter, you will see that that's it. In a similar way, I could put a value before the column or after the column. In this case, I'll put it after, and I'll say start from the beginning. That's what it means if we put the value after the column. So start from the beginning and give me values until a specific index. So which index should I use? I will use the third one. So 0, 1, 2. So it's the second index. If I put 2 here, yeah, of course the last index is not inclusive. It's not included. So that's it. So that extracted this part, this and this for me. So that's that. So again, I'll call the d2. I can show or extract a specific value from a specific location. So I can say d2, I want this. I get this value by calling 0. This index is 0 in the first dimension, is 1 in the second dimension. So I'll call 1, and then here 0, 1, 2, 3, and then if I enter, I get that 7. This gives me that value at that specific index location. So you can extract values by knowing the index positions of the value you are searching for, or the values you are searching for. Now from this example, we saw how it was sliced. I could also specify an index. I could combine that. I could combine the indices like this. So this is d2. I want to start at this index and go down everything, and then I want to also start at this index and go to this index but not included. So I'll be extracting these values. So I'm essentially starting here, going down, and starting here, going to this point. So this should give me 5, 6, 9, 10. Yeah, so this is also possible. This that I just extracted here, I could extract it or slice it again using negative indices completely. Using negative indices. So I want 5 and 6. What do? I know that this last one is -1. I want it included. I want this also included, so I start at -1 in the first dimension, and then I go to -2, -3, and then in the second dimension, this is the second dimension, the vertical. This is -1, this is -2, and this is -3. So I want to start at -2. No, I want to start at -3 and go to -1, -1 without including -1. So this that I've written will give me this same one here. What happened? What's going on? Oh, okay. The shape is 0, 2, so it means no elements in it. Yeah, what this means is, okay, I see the mistake. I'm not supposed to slice. That's in the first dimension. So the slicing is supposed to be, it should be the other way around. 3 to 1, not -1 to 3. -3 to -1. -3 is included. Yeah, okay. So the array I'm trying to slice is this, so it should be it should be -2. It should be like this, and then I get that array. The D2 again, no, D2. So it means start at -2, which is this one, get everything, and then in the second dimension start at -3, which is this one, this column. Start at -3 and give me everything until the last one, -1, and don't add it. So that's how it works. The problem in this error is the slicing. I tried to do it in the opposite. I was slicing from the bottom up, but it doesn't work that way. The slicing works from up down. It's from top to down and from left to right. That's if you are given the upper and lower bound. And if you are given the upper and lower bound, you slice from left to right or top to down. Let me make it more clear. If I do this, then I'm slicing from index 0, which is this one, but don't include the last one, because it's, again, it's the last index, is not included. For example, if we give D2 1, whichever way you prescribe you describe the slicing, it goes in one way. You just have to bear in mind that the slicing, you have to specify the slice that it goes from left to right or top to down. That's the important thing. That's what I've been trying to explain. I think that's enough for 2D arrays. We'll move on to 3D arrays. So I call 3 D3. So you see the shape of D3 dot shape, and then we get the shape. So it's 4 by 3 by 5. So 4 in the first dimension, 1, 2, 3, 4. And then the second dimension is 3. So the 3, these are 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Those are the second dimension. And then the last one, the third dimension, is the columns. 1, 2, 3, 4, 5. So this is, so 4 by 3 by 5. So in a similar way, if I want this part I'll just call d3 minus 1, and that gives me this. Similarly, if I call d3 0, it gives me the first part, this part. So understanding this is also very important. So what we can proceed to do at this point will be to now slice. We call d3 again. Let's say I want to slice this, or no, let's say I want this from this 31. I want this. I think this example will make everything very clear. So we call d3. We can do it with negative and positive indices. I'll do it with the negative indices. So I want everything from here. Okay, yeah, let me take it from this to this so it gets even more interesting. So 31 to 33 down. These are the components I want. So we go to the first dimension. In the first dimension, this is -1, this is -2, and this is -3. But I want this, so I'll start at -2. I'll say give me everything from -2 onwards. Then in the second dimension, this first one, -2, gives me this first dimension. It gives me everything. What I've highlighted falls in this code. This now I want the second dimension. The second dimension in this case is this is 3. So 1 2 3 1 2 3. I want everything from this 31 to this 58. Yeah, so in the second dimension I want everything, 1 2 3. And then in the third dimension I want 1 2 3. So it's -1, so -2 -3 -4. So -4 2 -1. This should give me this 31 32 33 to this point 56 57 58. Let's see. Yes, that worked. So if I didn't want everything, but I wanted to slice just maybe the top, the first 2 dimensions, then I want to slice the first 2. So I start at still using the negative indices, the colon, and I want to start from 0, and so -1 -2 -3. So I start at -3. So it will be -3 2 -1, and then it gives me this first 2 and this first 2. Okay, the comma is not in this, my bad, this error. Okay, so that's that. And what you need to also keep in mind is that when you slice you get arrays, and depending on the number of times you slice, the dimension of what you're slicing is exactly the number of times you slice gives you the dimension. For example, if I give this t1 is equals to, let's call this slice t1 and if I check t1 dot endem, it will be 3. But if I did or let's say I did t2 is equals to d3, then I pick let me first of all call d3, and then we look at it. So this is d3. I call this again, and then I call it t2 now, and instead of going from minus 2, I'll just call only that one, the minus 2, which would be minus 1 minus 2. So I'm just calling this, I'm doing the extraction in only this, not with this and this, but only this. So if I do this, then I do the t2 dot endem, it will be 2 because I sliced twice. The other one was specific, and I'll use the same example to create t3 and then in t3 this time also I'll slice it only twice. So in the second dimension I'm picking the third one. So we're here minus 1 minus 2 minus 3. So I'm picking this in the first dimension, and then I'm picking this in the second dimension because it's minus 3, and then I'll slice from minus 4 to minus 1, which will be here. So these are the values we should get: 31, 32, 33. So if I print t3, it's 31, 32, 33, and if I do t3 dot endem, it's 1. And then finally, if in my slicing I didn't slice at all, I just specified the indices. So first dimension, second dimension, and third dimension, the last value. So it's 34. This I already assigned it as t3 again, so I'll call t3, it gives me the 33. So at this point I would like to end the tutorial, and thank you for watching, and I hope that I was able to make Numpy or introduce Numpy in a very simple and concise way. And my suggestion to any new beginner is that you need to practice with the Numpy package and just play around it, and the more you play around it, the more you get familiar with its functions. If you play around what we just practiced today, you will understand everything. If you do everything by yourself, you will get better. So thanks for watching, and subscribe to my channel for more tutorials like this. Thank you.